Hi everyone, I'm Anuj. I'm one of the product managers working in ads transparency area at Meta. And today we will be talking about what does algorithmic transparency look like in the land of personalized advertising, and what are the things we have learned from launching why am I seeing this ad product on Facebook. This is definitely a Herculean effort by a huge team. We could not fit all the faces on this slide, but this is just a small number of people who were involved in the effort with support from many more teams at Meta. So today we will be talking about four things. The first one is what does the transparency for algorithmic transparency area even looks like? How did we build the product? Like, why am I seeing this ad? How do we measure the product? And what have we learned by pushing the product in production? This was the new version of the product that we will be talking about was launched earlier this year. So we will be sharing some learnings we have had along the way. So let's jump into the first topic. What does ML transparency for ads even look like? So Meta's user-facing ML transparency product is called as Waste. Why am I seeing this for ads? And this is a product that helps users understand why they were seen, why they were shown a particular ad on their Facebook feed or some other places. And this is available from a three-dot menu of each ad, and there are some screenshots running on the side. As you click into the product, you can see multiple reasons on why you were seeing this particular ad overall. And we will be going through some of these details as we talk through further. Let's take a step back and talk about where are we coming from. So ads transparency from Meta is not new. The first version of the product was launched like almost a decade back. The second version was launched like a couple of years back, and that showed advertiser targeting choices. What that means is that these are the criteria that an advertiser is setting for a user to see this ad. And this could be like, okay, Anuj is based in Seattle, that's why I want to show him this ad, or Anuj is between age X and Y, and that's why Anuj should be shown this ad. With the recent launch of this product, something we called version 3.0 internally, we also started showing the user activity signals that a user is doing on and off Meta technologies, because of which Anuj could be seeing an ad. So for example, if Anuj is liking a lot of, let's say, Adidas, Nike, or Reebok pages, tomorrow Anuj could be shown a shoes-related ad overall. And this was built with a lot of policy stakeholder, privacy stakeholder feedback, user feedback. And users had indicated that the previous version with only advertiser choices did not provide them enough information. And users highlighted that maybe it was not the real reason that they were seeing that ad as well. And there has been a bunch of public research about this whole area also. So let's look into what does actually the algorithmic transparency looks like. So the first screen over here is the landing page of Waze. So when you go to any ad, you click on the three-dot menu, which is the three dots on the top right side of the ad. You come in over here. You click on why am I seeing this ad. You see the first screen over here. At the very top, we show to the user why you are seeing this ad. And then there are two sort of major CTAs, advertiser choices, which is the targeting criteria. And then the second is the your activity. And at the bottom, we also show like, okay, what can a user do about this, so that in case a user wants to influence their ad experience in some way, they can go and take certain actions as well. And at the very bottom, we ask the user, like, was this information even helpful to them or not? When a user clicks into advertising choices, they come to the second screen over here. And that's where the targeting criteria an advertiser can set, which is like, oh, I want to reach people whose primary location is United States, whose gender is X, whose age is between X and Y. If a user clicks on your activity section, that's the third screen on the right over here. This is divided into two parts. The actions a user has taken on Meta technologies, which could be like Facebook, Instagram, etc., or a user has taken off Meta technologies as well. We wanted to make sure that users can understand this. Like, this is not sort of technical jargony language that a normal user would not understand. So this is phrased in a language that an action a user has taken historically, so that when a user is seeing this, they can relate back like, okay, yes, probably I took these actions couple of days, X time back, and that's why I'm seeing this ad overall. We also sort of distill the information for the user so that it's easy to consume. You will see like 3-4 sentences over here instead of many sort of granular details that also go into like ad ranking overall. We up-level the information to a topic level so that it's easy for user to consume and they can influence their ads experience as well. What have been the sort of learnings from launch? We launched the product starting in February 2023. On the right, this is the announcement post by Facebook President Nick Clegg. We have heard some positive feedback from policy experts and other stakeholders. And some people mentioned that this is a unique level of transparency that we don't see at other places. Being proactive and giving users sort of more information on why they are seeing something is always better, and it could help alleviate a lot of consumer concerns that come along. And the topic level explanations definitely seemed a right step in the right direction to stakeholders. And providing people with clean topic with easy to consume information can reduce the confusion that people might have overall. And from a user sentiment perspective as well, so from the question that was in the bottom, that was this explanation helpful or not, we saw an increase in the user sentiment that users were saying that yes, it is more helpful to them. With that, I will invite Rajesh to talk about how did we actually build the product.
Hi everyone, my name is Rajesh Shenoy. I'm the engineering manager supporting the team. So this was work of a lot of engineers in the team. Thanks Anuj for introducing the product. So I'll go a little bit more into the engineering details of how we build this product. This is not the full survey, so pardon me if it's a little bit at a high level. So one of the challenges we have is ads are being delivered using machine learning models, which actually uses users' activity and features from the ad itself to deliver an ad. And so one of the core problems here is that how do you explain the machine learning model? Fortunately, this is an area which a lot of people have worked on for last few years. There are several different algorithms. These algorithms are called attribution algorithms. What they do is once you have a model which is predicting a set of outputs for a set of features, you can actually predict which features are important for this model. So one of the algorithms is something called integrated gradients, which sort of looks at the gradients which are propagated in the model. Another example of an algorithm is feature ablation, where you try to remove one feature at a time, and then you look at what is the difference in predictions between the different features. So what is the big challenge? The biggest challenge we have at Meta is actually the complexity of the system. So the ads rank system is a multi-stage delivery, which uses multiple different machine learning models, and each stage sort of prunes down the number of ad candidates you show to a user. And there are hundreds of these models in production today, which are being continuously modified by hundreds of engineers. And the objective function which you use to decide an ad is a very complex objective function, which includes multiple components. And the ad decisions are also made per request level. So as soon as you are viewing Facebook, you actually make a request to the ad server, which gets ads to the user. So this means that we actually had to provide explanations per request. So one of the ways we sort of simplify the problem is only worry about the last stage of ranking, because this is the last stage which decides the ad which is shown to the user. But even in this last stage, there are multiple models which contribute to the prediction score. So the second big challenge we have is the complexity of the input. On the right-hand side, this is how our recommendation system looks like. This is a paper which was published a few years back. So our machine learning models use different types of features, what we call dense features, which are floating point numbers. We also use sparse features, which is actually an interaction of a user with a particular page or an ad. And some of these sparse features get compressed into embeddings, which is a continuous representation of the sparse features. A lot of these features are not human understandable, and some of these features are collinear, because some of these features get diffused across multiple inputs to the model. And there are tens and thousands of features per request. We also required this product to show the explanation within 2 seconds when the user is actually browsing the ad. And if you look at a lot of the industry academic papers which talk about attribution algorithm, they run in the order of thousands of, they scale the number of input features, right? So in the order of thousands of features. So how do you solve this problem? So I think that the approach we came up with is actually to build an explainable model. So the production model is very complex and it's very difficult to explain. And the way we build an explainable model is to use the user-side sparse features. So these are the interactions the user have with specific ads or topics, ads or pages. And these sparse features can be mapped directly to user activity. And this also reduces the attribution diffusion. So we are able to sort of compress attribution into the specific features. So how do you make sure these features and this explainable model actually reflects a production model? So we use a technique called knowledge distillation, which is to sort of distill the knowledge from the production model into a explainable model. So this is a well-known approach in machine learning. And then we also try to align this production explainable model close to the production model. So I'll explain some of the metrics we used. And this, using the separate model allows us also to have very specific optimizations to reduce the latency for this product. So the last part we had to worry about was how do you take these input features and convert it into a form which is easier for a user to understand. So if you look at the top part of this picture, you have features which are basically IDs or numbers. And then we have a system called a feature value translator, which tries to convert these IDs into human understandable sentences. Typically, most of these IDs have an entity associated with them. For example, the name of the Facebook page or the name of the ad you interacted with. We convert those entities into topics, which uses a specific taxonomy we work with policy on. And then we do an aggregation of the topics. So at the end of all this process, we get a sentence like, you interacted with an ad about apparel. So I'll go a little bit into how we measure the quality of these explanations and what we learn from production. So as I mentioned to you earlier, we built this explainable model, but we need to ensure that this model actually reflects a production model. So one of the metrics we used for this was what we call ad flip rate. So we looked at the features which are used in the explainable model, and then we remove these features from the production model and see whether the ads actually change ranks. So this is what users also expect from an explanation. If these activities didn't happen, did the ad even get served? We also use other metrics to ensure the model aligns with the production model. So metrics like normalized entropy, prediction error, R2 score, and we also look at the drop in prediction from these features of the production model. So to ensure that these explanations actually are relevant to the user, we also used a human evaluation of these explanations, and we ensured that this explanation is relevant, and we used it as a guardrail metric for our product. So the biggest question we had was when we actually build this model and shipped it into production, what happens when the actual production models themselves evolve? So this is a graph of how our metric, which is the ad flip rate metric, evolved over time once we launched the product. So typically we see that when the new production model is deployed into production, our metric drops, but then it catches up automatically to the production model after a while. So we still need to sort of continuously build these models and ensure these models track production. So there is actually investment needed to keep these explainable models aligned to production models. With that, actually, I'll open it up for questions.